Here's integrated 3. It's CL10-201, letter C. So they give you this series, and hopefully you said that it was geometric, and hopefully you said that you can determine its sum. You can determine a sum of an infinite geometric series if R is less than 1. Well, if it's in between 0 and 1, if it's a fraction, like a proper fraction. Okay, so if it has a sum, what is it? So there's a formula for the sum, and I think I have it memorized. It's just A over 1 minus R. That's just a formula that you might want to memorize. It's the formula for the sum of a geometric series where A is the first term and R is the multiplier. And I can show that to you in your math notes box. It's right, I don't know what page it's on in your book, but it's in a math notes box and it's right down there. Okay, so for an infinite geometric series with an initial value of A and a multiplier or common ratio R, where R is in between 0 and 1, the sum of the series can be represented by this. So I just go A, I just memorize this part, A over 1 minus R. So what's the initial, I need like the first term, like the initial term. So I'm going to start wherever it tells me to start. Like it's telling me start at 0. Sometimes it'll say start at 1, or usually it'll either be 0 or 1. So I plug a 0 in here. Anything to the 0 power is 1, and 1 times 4 is 4. So A has to be 4. And then 1 minus R. But I know R is negative 2/3. So I'm going to go plus 2/3. Because if you minus a negative, it's plus, right? And then, so this is really 3/3 plus 2/3. So this is like 4 over 3/3 plus 2/3 is 5/3. And I like to do that thing where you flip and multiply. So I'm going to say that's 4 over 1 times, I'm going to flip this, times 3 over 5, and I'm getting 12 bits. Unless we can check that and see if that's right. Yep, 12 bits. So that's just in your math notes box.